Good afternoon, good evening, wherever you are on earth. So, welcome to another edition of Ballerina Community Call. So, before we start the proceedings, I'd like to remind you a couple of things. So, this is a recorded session, and also it's live. We are broadcasting this on YouTube live as well. And so, if you like to ask questions while I'm doing the presentation, that's perfectly fine. Please interrupt and ask questions, and that's encouraged. And also, you can ask questions via YouTube comments, the Zoom chat, but I may not be able to see them at that moment. So I would recommend you to interrupt me and ask questions. All right. So I'll be doing the presentation today. So you get to hear me babbling throughout the session. All right. All right. So if in case there are new people, I did this slide just to explain a little bit about Ballerina. I won't take much time. So it's an open source language for the cloud, and it makes it easy to write network services or use network services and combine them to produce systems. So today the topic is about batteries included, mostly about package manager and the dependency manager. So it's Ballerina, not just a language, but it's a full platform that includes all these capabilities. Comes with the standard library, build system, test framework, a way to document your code, and IDE support via various IDE plugins, VS Code mostly. And our primary goal was to design a programming language that is familiar with, that's familiar to people who are already familiar with C-style languages. Anyway, today's topic is mostly about the package management, dependency management, and how do you overcome, or what are the measures that we have taken to minimize the dependency health, right? So when it comes to managing dependencies in Ballerina, I would like to talk about specifically these topics today. There are some other topics. I don't think we'll have time, so maybe we can discuss them in another session. Let's start with a quick introduction to the Bal command. It's a build system, it's package manager, it has many phases. And also, I'll do a quick demo, like how to work with packages. It's going to be a very quick demo. And I'll show you what do we mean by dependencies, how do you look at the dependency graph, dependencies.toml, modules, and things like that. And in Sonalic Beta 3, we have added automatic version updates. I'll a couple of slides on that as well. Then the compatible version ranges. So this is also important because this gives an idea on what are the compatible versions. Let's say you are currently using in one version, and what are the other compatible versions that you can upgrade to, right? So let's try to quickly cover these topics, let's say in 30 to 40 minutes, and see how it goes, all right? Bal command is a multi-purpose tool. We have already Bal tool at the moment, and it has many roles. It works as a build system because you can use Bal build, Bal run, Bal test commands to basically build and test and run your Ballerina programs. It works as a package manager because it allows you to organize your source code and then even build and pull dependencies. And also, if you are developing a library, it allows you to push your package or share your package with others. Right? So it works as a package management tool as well. So various commands, these are the commands. And also, Bal command works as an update manager, self-update perhaps. So when you install Ballerina onto your local workstation, you can use the Bal command to update the platform distribution as well. Basically, baldist and star commands, right? So there are other uses. I'm not going to talk about them today. Right? So what do we mean by a package manager? So this talk is mostly around the package management system in Ballerina. A package manager usually provides a mechanism for developers to organize a source code, version them, and build and share. Right? When you mean build, we can build an executable, or if you're developing a library, it allows you to package your source and share with other people. Right? So this is basically common functionalities of a package manager. And it also fetches the correct versions of the dependencies. If you're trying to do manual dependencies, it's going to be really hard because typically a non-trivial application will end up having direct dependencies. And those direct dependencies, there are dependencies, we call them transitive. So you would end up with 20 to 30 or 100 dependencies, and manually working with them is really hard. So the package managers usually allows you to fetch all the dependencies. You don't have to worry about versioning. You don't have to worry about anything. I'll show you a demo on that as well. So another interesting fact about Ballerina is you don't have to specify versions even to start. Let's say you found a source code somewhere in a tutorial or internet. You can copy that source code into a Ballerina program. We just need to do bal build. Ballerina package manager figures out correct versions of all your dependencies and download and use them. We'll see that. Then it also keeps the dependencies up to date. We have a couple of slides on that as well. And also, package manager allows you to achieve repeatable builds, as in you can, let's say you did a build today, and that build uses versions of the dependencies. There is a way to basically achieve the same build with same dependency versions. I'll have some slides as well. Okay. So before we start, I'd like to start with a Ballerina source file concept. So you can start, if you're not working on a large project, if you want to try out Ballerina, one option is to use the single source file, right? You can just open an editor, and you can name that file with the extension bal, and that's all you get to do. And then you can do bal run if you want to just try running the program. This bal run command won't produce an executable, but it will just run and die. Then the other option is you could do bal build. It will create an executable, and then you could do run. So this is a source file. This is simple, but it's easy to get started, but this option is very limited. You don't have a way to configure the versions of your dependencies, and there are many other limitations in this approach. So we don't recommend this for serious applications. So next is the construct. We call a Ballerina module. So it's a module, and you can define it as a set of bal files, but it's a bit more than that. It is actually a namespace, right? It's a namespace, and within the namespace, you can have all your module level identifiers like functions, your types, constants, variables, and modules allows you to achieve modularity, code reuse, encapsulation, stuff like that. In a module, you can have public identifiers like public functions, public variables, public type definitions. All of this forms the external view of a package. Now, a Ballerina program is a combination of these packages. That's how we see a package at runtime even. It's all about modules. If you look at the language specification, the specification talks about modules, right? And a module can depend on other modules as well. But what we have realized is module is not enough to package your source code and share them with other people. Module is a little bit low level, but we need a little bit high level construct to support like other capabilities in a package system. So we call that construct as a package, right? So I'll get to the package construct in the next slide. So what this slide shows is how we have mapped a module construct into a file system, into the file system. So a module, as I said earlier, its module contains source files and the resources, test source files, and test resources. These are the four main things that you can have in a module. And when you look at the module directory, this is roughly the structure you see. So these source code are the normal source files that you see in the module. Then you have resources, module resources. Then you have test, module level, we call them module level test. These tests test the functionality of a module in isolation. And then you have test resources. And you can have any other file here, any other files, and we simply ignore them. We only care about these four things. Okay. Then the package. So package, you can think of a package as a collection of related modules, right? And then packages can have versions, and a version of a package is applicable to all the modules that are there, right? And package is the mechanism that we use to share code. I'll get to that later, but I'm sure you have heard about Ballerina Central. So Ballerina Central is a package repository, and it contains a collection of packages. So when you share, if you want to share some code as a library, an API with others, then you need to package up your source code as a package and version them. A package has two formats. One is a source format and the distribution format. The source format is the one what you see inside the package directory. Like when you create a package in your machine, what you typically work with is the source format of a package. Then when you are ready to share your package with a package repository, then only you create a distribution format of a package. We call them Bala files. You typically do that with bal build-c command. Okay. So package, as I said, is a collection of modules. So this diagram shows a package with a single module, right? The name of the package is GraphQL. I use GraphQL as an example. And then a package has something called ballerina.toml file. This toml file identifies a directory as a package, right? And then package can contain one or more modules. And there's one special module there. We call it the default module. The default module, the name of the default module is same as the package name. So package is GraphQL and module is GraphQL, right? So this is the concept of a package with a single module. Now, when you map this to the file system, a source format, this is what you see. This is the package directory. You can see the ballerina.toml file. The other content that you see here, the bal files, resources, test, they belongs to the default module. So we overlay the default module onto the package directory because it's very common to have packages with single modules. So we didn't want to create additional directories to store the module. So basically, the default module is at the root of the package. That's how we have designed this. All right. So now let's look at a package with two modules, or three modules rather. So we have the default module, here the GraphQL.types, GraphQL.parser. So as you can see, the module name always starts with the package name, right? The default module inherits the default module's name is same as a package name, but all the other modules, they start with the package name, module, GraphQL.types, GraphQL.parser. So when you look at the directory structure, you see the Ballerina toml and you see the default module here, default modules, bal file, default modules, resources, and all other modules goes inside this modules directory. They have the same structure as other modules. All right. So this is about packages. Then the package repository allows you to store all the packages. And in a package repository, the structure is we use some kind of a hierarchy, organization name, package name, and version. Organization is a way of grouping packages, right? It's like similar to GitHub organizations. And then you have package names, and package names can be hierarchical. One example is here. Here, Ballerina X is the organization name. Package name is AWS.S3, the hierarchical name. And you can have AWS. Other services provided by AWS. Package versions follow similar. And we have a default package repository that is called Ballerina Central. And it is connected to the bal build command or rather the bal command as well. So the next question is where should I specify package versions? Now I've been talking about package structure, directory structure, and all that. Now the next question that we should think about is where should I specify? Now, as I said earlier, you don't have to specify. It's not a must. You don't have to specify because the bal tool figure out all your versions. But in case you want to force versions, we have a solution. We'll talk about that later. Okay, so I'll do a quick demo packages. Any questions so far? Okay, so you can, I'll use bal new. Let's use hello as the name, right? I'll use VS Code. I just not going to introduce packages, but I want to show you how we manage dependencies. All right. So let me do a quick HTTP client usage just to show the dependencies, how we manage dependencies. So Ballerina comes with HTTP standard library, and it has a client. You can use this client to invoke HTTP services. Let's say I want to get some jokes from the internet. Let me make a Joker endpoint. New. I'm not trying to run this service. Right, the random URL. So this can fail. So I'm going to use check, and I use error question mark. So if an error happens, the main function returns with an error. Okay, so I'm going to use Joker endpoint. So get. Let's say I want some random jokes. That's all. And then let me assign this to a JSON payload. All good. And I would use IO package to print the joke out. I assume that there will be a payload field in the JSON. That's all. It's a very simple program. I just want to show the dependency management aspects of this. Okay. So now, as you can see, we have only Ballerina file and the main bal, right? The Ballerina file is empty. It doesn't have the package organization name, package name, and version because we default them. The organization name default to your username. Package name defaults to the directory name, which is hello. Version is defaults to 010. So when I do a bal build, so you can see that it's compiling my package. Organization name is Samira, package name is hello, and the version is 010. You have the option to add them and modify if you want. So now it generates the executable. I'm not planning to run this, but it generates me a there are no changes to the Ballerina, right? We are not modifying the Ballerina because it's a user managed file. Ballerina is managed by the developer. It's not managed by the tool. Whereas dependencies.toml file is managed by the tool. And we don't encourage people to update or modify this file, right? So let me collapse this. So dependencies.toml file contains the dependencies resolved, or dependencies and their versions and everything resolved in the previous compilation. No, I just did a compilation via bal build, and bal build basically resolve all my dependencies, their versions and all that, and it captures everything in the dependencies.toml file, right? So it says I'm using crypto package version 2, and it depends on these other packages. I'm using file, all that. I'm using HTTP. So sometimes it's very hard to read this. So if you want to visualize your dependencies, I think we have a command to get the dependency graph. Let me see whether that works. So what you can do is we are planning to introduce a command called bal graph or something similar. Right now we don't have that. So what we have instead is bal build, I think, dump graph. So this dumps the dependency graph using the dot format. So let me copy this file. Right, so using the dot format. So I can visualize this here. Let's say graph is online. Right, so if I put it here, you should be able to see things. Let me download and open it. Yeah, so this is the dependency graph of my hello module that, and I have used just the HTTP. So these are all standard library dependency graph. Like you can, so I just want to tell you that even though you have very simple code, a few lines of code, but your underlying dependency graph can be simple or complex. In this situation, we are dealing with various versions of standard libraries, right? So sometimes it's better to know the dependencies that you are depending on. So this is a good way to visualize and also even troubleshoot. If you have any issues with the dependencies, you can use this command to troubleshoot the dependency resolution issues as well. So this is about dependency graphs. So as I said, we don't encourage people to update the dependencies.toml, right? So one thing I want to tell you is that, so as a developer, when you get started, we just want the source code and specifically the imports. Based on the imports, we can figure out all the versions of packages. Even like, let's say, okay, let me go to Ballerina Central. Let's say I want to use some regex library. I think I can see there are two. First one is coming from the standard library. For this demo, I'm not going to use that, even though that's a great, simple, it has a simple set of simple yet comprehensive functionality. I'm going to use this, the other regex library, which exposes a Java API as a Ballerina API just for the demo, because it's not a standard library, it's external. So I'm going to copy this code, something like this. I think I have to add the import as well. So when I do that, I think I have already used it. But when I do bal build, it's going to update my dependencies.toml file with the correct version of the regex library. So let's see. Let me search for regex here. Yeah, so I can see, so this is my package, and this is the regex, that library that I used. So I think the idea here is when you work on the source code, you can add your dependencies, you can remove dependencies. And most of the time in Ballerina, you don't have to worry about the dependency versions and basically cleaning up your dependencies and things like that. Because the Bal tool, most of the time, it takes care of everything. So if I remove this, when I do the next build, it's going to clean up my dependencies toml, and it's good to go. Right? So that's a quick demo on working with packages and managing dependencies. So let's quickly go through, I think we have a few more minutes. Let's quickly go through the automatic version update capability. So with Swan Lake Beta 4, we have added automatic version updating. We know that it's a double-edged sword or necessary evil, right? Because the extreme, at one extreme, we can say we don't do dependency updates. So it's up to the developer to manually update dependencies. We can provide tooling, but it's a conscious decision. On the other extreme, we can say we always update dependencies, and we always give you the latest possible version that is available on Central. That's the other extreme. So I'll explain our design in the next slide. What's the policy for updating versions? So in this slide, the bal command automatically pulls and use new versions every time you do a bal build. Literally not every time. We do that every 24 hours in Swan Lake Beta 3. I think right now you can't change this, but we can enable you to configure this frequency, right? But the idea is you can even configure after that, you can configure bal build command to update dependencies every time automatically. What do you mean by update? When I do the bal build now, it creates the dependency toml file. Let's say there's a new version of my dependencies added like 5 minutes after that. Then I do a bal build in the next hour. My dependencies.toml file will be updated to use the new version. That's how you get notified that we are using new versions, right? So you can argue this both ways. Some people say automatic updates bad, but some people say automatic update is okay, as long as we can minimize the damages. And also, you need to be aware that automatic version updates with build makes build non-deterministic, because you get new versions every time you build, not literally every time, let's say every 24 hours, but still, right? So we have taken several measures to minimize the damage, like introducing sensible version ranges. I'll talk about that in the next slide. Okay. So to minimize the damages or the issues that are caused by automatic version updates, we have sort of introduced some concept called locking mode. So we thought about 3 locking modes in the design. So one, soft lock, which means every time you build, we update the latest major version, right? Latest version, as in major locks. We lock to the major version. Like if you're right now using version 100, we just lock that major version component, that is 1. We don't update that. We don't automatically go to 2, but you can go to 100 to 150, 110, 120. That's all allowed in the soft lock mode. Medium lock mode locks the major version component of your dependencies and also lock to minor versions. I'll explain the if possible class next slide. So you can think of like, if I'm using version 1.2.3 right now, and if there are new versions like 1.2.5 and 1.2.1.3, we automatically update to 1.2.5 version. That's a medium lock. Hard lock is basically we don't update. It's locked to minor and patch, major minor patch components. So the default locking mode that we use in build is a medium locking mode, right? Basically, we automatically update to the patch version. So basically, for every dependency, we update the latest patch version, right? Now, there are edge cases here. We just would like to explain that as well. Let's say the example here is package A requires version 1.2.3 of package Z, package C. Let's say, and the package B requires 140 of. Now, as you can see, both A and B requires different versions of package C, and they are not in the same patch version range, but they are in the same minor version range. So even though we are using medium lock here, we have to take a decision now, right? Because they are not in the same medium lock range. Basically, there's a change in the minor version here, and we can make it even complicated. Let's say there are latest versions of C in Ballerina Central, and those are 150 and 210. Right? Now update manager or the package manager now has to take a decision. To which version it should update. Now we have to see the version of C. Now, based on the medium locking mode, we pick version 1.4.3. Right? So we don't go all the way to the next major version. We don't go all the way to the latest version here, 1.5, but we take the sensible version that is 1.4.3. That is the least minor version required to satisfy these version requirements. Right? So these are some edge cases, but I thought it would be good to cover these as well, and because these things can come as surprises later in the development cycle. All right. Then the compatible version ranges. In version upgrades, we need to think about what are the compatible version ranges in the language. So we follow SEMVA compatibility, and also we follow the compatible ranges defined in Rust. Our model is very similar to that as well. So the idea is versions are considered compatible if they are leftmost non-zero component is the same. I'll explain by examples. So here, let's say 1.2.3 and 150. We say these two versions are compatible because they are leftmost non-zero is 1, right? Left are same. So here 1, 1, that's compatible. But here it's 1 and 2. It's not compatible. So in this example, leftmost non-zero digit is 8. So that's same. So we say it's compatible. But here leftmost, I think there's a typo here, additional 0. See 8, 9, they're not compatible. Now the same rule applies here. Non-zero, leftmost non-zero is 1 and 2. They are not compatible. So that's an easy way to figure out the compatible version ranges in Ballerina. When it comes to pre-releases, usually pre-releases are something like major, minor, patch like alpha, beta versions. We say pre-release are compatible if their major, minor, patch versions are the same, right? So that's about compatible version ranges. The next topic is automatic version update is good, it's great, but there are situations where you need to turn it off, right? Sometimes you want to get repeatable builds with the exact same dependencies used in a previous release. So we added this balbuild - sticky option to achieve that use case too, right? So if you have a dependencies.toml file, that's great. You can use balbuild - sticky. You get the exact same set of dependencies. But if there's no dependencies.toml file, we just ignore this - sticky. You can't do anything about it. Right? Sometimes when you do a release build, we recommend you to use sticky so that you can use the tested versions. Then the offline builds. So sometimes you want to do offline builds and you don't want to access network during the build. Mainly, if you want to fast builds, if you want to do like quick edit debug cycles, then offline option is great. You can get quick compilation times. What it does is it tries to access packages stored in the local caches. So whenever you pull packages Ballerina from central, we store them in the local cache. Some local cache is in your, I think in your home.ballerina directory. So offline, try to see whether all the dependency versions that are specified in the dependencies.toml file are available in caches. If that's the case, you can, otherwise it will fail. All right. So I think we quickly talk about some of dependency management capabilities in the language, some of the stuff that we have added in Swan Lake Beta 3. I know it was a quick session, and I tried to cover a lot of details as well for future references. And thank you. If you have any questions, we can look at them now. So I can see one question. Is the graph directive is in SL Beta 2, SL Beta 3? I think we added this in Beta 3. Yeah, I think Joe has answered anyway. Okay. Any other questions? Let me stop sharing. All right. Thank you, everyone. Thank you for joining. We'll see you in the next community call. And I think I'm not sure. There'll be a survey regarding the Ballerina community call. And if you get a minute, please try to fill that and submit. Thank you. All right. Enjoy your rest of the day. Bye.